GeeksforGeeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success. Commit with GeeksforGeeks.
Hello everyone. My name is Mansi Lokakshi. I am All India rank 48 in GATE 2023. So today we are about here to do marathon session on digital subject. Okay. So let's start that by solving some interesting questions on digital, and you can post the chats. You can comment. Okay. So let's start with the subject. So let me present my screen. Okay. Okay, let's begin with the session. So you can see the first question. It is advantage of synchronous sequential circuits over asynchronous one. So the option 1 is faster operation. Option 2 is ease of avoiding problems due to hazards. Option C is a lower hardware requirement. Okay. Option D is better noise immunity, and option E is none of the above. So what is the solution for this? So it is like, so if you know that synchronous means less chance of hazards, okay, but can only increase the delay. Okay, so synchronous circuits cannot have faster operation than asynchronous one, but it is easier to avoid the hazards. So in synchronous circuits, so we can say that option A is false and option B is true. And why C and D are incorrect? Because it is false if we do not consider how to avoid the hazards in asynchronous circuits. So that's why C option is false. And option D is false because it is necessarily true. So we don't want necessarily true here. Okay, we absolutely want the statements to be true. So often asynchronous have better noise immunity. So that's why it is not necessarily true. So let's write the reasoning for this. So option A, let's write it that synchronous synchronization means less chance of hazards, but can only increase the delay, Okay, so synchronous circuits cannot cannot have faster operation, cannot have faster operation. So as per to that, option A is false. Okay, option A is false. So as the operations are not fast, then asynchronous one, it is easier to avoid hazards, okay, in synchronous circuits. So that's why option B is correct. Option B is correct. And what is the thing for option C and D? That option C is false because if we don't consider how to avoid the hazards in asynchronous circuits, okay. And option D is that often asynchronous counters have better noise immunity. So these are the reasons. These are the reasons. That's why they are incorrect. That's why option A, B, C, D, and E are incorrect. Okay, and option B is correct. So the correct answer is. So the correct answer is B. I hope this question is very well clear. Let's move on to the next question. So as you can see this question, okay. So this is a question that the figure below shows D-type flip-flop are connected. Okay, D-type flip-flop are connected here, like for shift register. Okay, so so what is this? This is a form of register which is like shift register, and is using a XOR gate. The initial state and the 3 subsequent states for the clock are shown below. So what is given to us? Already the subsequent states are given to us. Okay, already the subsequent states are given to us. Now here the diagram is shown. Can you see that the diagram is shown? Okay, states are also shown, that first is initial, after the clock, after the first clock, after the second clock, after the third clock. And they are asking us the state, okay, they are asking us the state QA, QB, QC, QD. Okay, after the fourth clock pulses, and as this is the shift register, so what will be the answer? It is very simple. Okay, it is very simple. Why? Because as you can see that, so this is C. So what is the input giving to this? Okay, what is the input given? It is C XOR. So can you see that this is the symbol of XOR? Okay, so QC XOR QD. QC XOR QD. Okay, and this is giving the input to QA. So that's why here we will write to QA. Okay, to QA. So so here third clock is there and we want the fourth one. So obviously we will check for this and this. And you know that whenever we are using the XOR gate, so what is the truth table? Okay, what is the truth table? Let me show you. So let's say we have A, let's say we have B, and A XOR B. Okay, A XOR B. So what the combinations we will have for two variables? It will be 0 0, 0 1, 1 0, 1 1. Okay, so these are the combinations we will have for two variables. What is the result for A XOR B? It will be 0, because for similar inputs the truth table for XOR is 0. 0 and 1, it will be 1. Okay, because it is for different, it is 1. 1 and 0, it will be 1. Okay, and 1 and 1, it will be 0. I hope this is clear. The truth table is absolutely clear to you all. Now on the basis of this truth table, let's find the input for QA. So here our QC is 0 XOR 1. Okay, and so what is 0 XOR 1? 0 XOR 1 will be 1. 0 XOR 1 will be 1. So what is the input giving to QA? So here we will have 1, and after that, as this is the shift register, so that basically means right shift will happen. So 1 will come here in the place of QA, and 0 will shift here, 0 will shift here, and 0 will shift here. So what is the answer? The answer is 1 0 0 0. Okay, I hope this is clear, like how we perform the operation. So which is the correct one? So option D is correct. Option D is correct. As you can see that how lengthy the question was, okay, such a big diagram and table and everything, okay, but can you see the solution? Only 1, 2, 3, 4 steps are required and we are done with the solution. Okay, so that's how sometimes the question may feel like it's difficult, but it is not. If you will solve that questions patiently, so you will get the correct answer. Okay, and you should know the basics. For like here the basics are, what is the truth table of XOR? Okay, so what is shift register? They will not clearly mention here that it is a right shift register. They will only mention shift register, but you all know that shift register means right shift register only. Okay, and you should be clear about what is a right shift, how the right shift is performed. Okay, so whenever the input is given here, rest all the outputs are shift, like here we did. Okay, so likewise shift is performed. So I hope this is clear. Let's move on to the next question now. Okay, so the question is, what is the minimum size of room required to store the complete truth table, okay, of 8 into 8 multiplexer? So the options are given below. 32K into 16 bits. Option B is 64 into 16 bits. Option C is 16K into 32 bits. And option D is 64K into 32. Okay, so let's see this. Let's see the solution for this. So it is multiplying 2 8-bit digits, okay, will give result in maximum 16 bits. Okay, it will give result in 16 bits. So total number of multiplication possible, okay, it will be 2 to the power 8 into 2 to the power 8, which is 2 to the power 16. Okay, and how we can write this? So it is, so hence space required will be, it will be 64K into 16 bits. Okay, 64K into 16 bits. So this is how it will be. Okay, so if we break this, so 16 means what? 2 to the power 4, and 64 means 2 into 2 into 2 into 2. So 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64. So 1, 2, 3, 4, 5, 6. 2 to the power 6. And this kilo means 2 to the power 10. Okay, so this is how we did. So I hope this question is clear. Let's move on to the next question. So this is a bit similar type of question, but it has something different. Okay, something different variation it has. So let's see this. So what is the minimum what is the minimum size of room? Okay, so what is the minimum size of room to store the required option? Okay, so the complete truth table we have to store. Okay, so this is the question. Earlier it was repeated. A room is used to store the table for multiplication of 2-bit integer, and now here the word mentioned is assigned integer. You know what is the meaning of assigned integer? So that means it will always have positive number. Okay, it will always have positive number. And now earlier in this question you can see that here no specification of like it will be signed or unsigned. But here in this one, they have specifically mentioned that it should be of unsigned integers. Okay, so the size of room required is, now let's see this, when we multiply, when we multiply two 8-bit numbers result can go up to 16 bits. This is in the previous question I covered. Okay, so we need 16 bits for each 16 bits of each of the multiplication result. Okay, and what is the result possible? Okay, so number of result possible is equals to 2 to the power 8 into 2 to the power 8, which is 2 to the power 16. Okay, which is 2 to the power 16, and we can write it as 64k. Okay, we can write it as 64k. So we need to store all possible result of multiplying to 8-bit numbers. So what is the answer for this? It is similar. 64k into 16-bit is the answer. So here the keyword is for to make you confused, like is there something which they have added in the question or not? But using this keyword, the answer hasn't changed. Okay, it is same as 64k into 16. Okay, the answer will be same. So what is the size of room required here is 64k into 16 is the answer. Okay, now let's see the essential prime implicant of the Boolean function. So the function given here is ABC is the function, and the equation given here is A bar C plus AC bar plus B bar C, and various options are given to us. And to make it like prime implicant, first we have to make the K map. Okay, so let's make the K map for this. So the K map will be of 8 cells, and how to make them like this. So this will be the column 1, column 2, column 3 and column 4, and here it will be like this. Okay, so this is A, this is BC. This is how we will divide, because the bits the function variables are A, B, C. So this is the this is how the division will take place. And so first of all, whenever we have written, so the the equation given here is A bar B plus A C bar plus B bar C. So whenever we try to implement essential prime implicants, okay, so we always make sure that it should be in canonical form. So what is canonical form? That in every term all the variables of the function should be present. So that is called as canonical form. So is it this equation is present in its canonical form? No, it is not present. Why? Because you can see here C is missing, here B is missing, and here A is missing. So you can say that absolutely this is not in the canonical form. So what you have to do, you have to first make this into the canonical form. Make it into its canonical form. So let's try to do this. So So how to make this into the canonical form? So we will see. So here A bar, let's leave the space for B. Here C plus, this is A, let's leave the place for B. Here C bar plus, here let's leave the place for A. Here B bar C. Okay. So here A bar, that means it is 0. The space, so this has the possibility, this has two possibility. Either it can be 0 or it can be 1. So as you all know that whenever we are saying digital, okay, digital logic design, so only binary values are there. Like it is either it is 0 or it is 1. Okay, no other value comes in the space. So let's make the possibility that it can be 0, it can be 0 or it can be 1. And here C represents 1 value. Okay, so let's write it as it is. Then here same we will do. So A is represented as 1 and 1. Now C, this place has two possibilities, which is 0, 1, and C bar will be 0 and 0. Okay. And here for this space it will be 0, 1, and here B bar will be 0, 0, and C will be 1 and 1. Okay, C will be 1 and 1. So let's make the mean terms for this. So can you see that we can easily get our mean terms? Like this is 1, this is 3, this is 4, this is 6, this is again 1, and this is 5. And repeated values we don't have to consider in the mean terms. So what are the mean terms given here? So for function A, B, C, the mean term values are 1, 3, 4, 5, 6. Okay, so please understand that whenever we have to make essential prime implicants, okay, when we have to take out the answer for such type of questions, make sure that the expression should be in canonical form. If it is not, this is the method to first make it into canonical form. Sometimes in the questions they will give you directly the canonical form, and simply you can take out the mean term values and you can put here in the k bar, or else you have to take out yourself the mean term values. Okay, first convert it into canonical form, then take out the mean term values and then put it into k map. So these are the steps you have to do. Okay, so the mean term values are 1, 3, 4, 5, 6. So let's put the k map mean term values. So here it will be 1, this one, and you all know that how to name the cell number. Okay, so this is 0, this is 1, this is 0, 0, this is 0, 1, this is 1, 1, this is 1, 0. Okay, so this will be 0, 0, 0, the cell number is 0. This will be 0, 0, 1, so this cell number will be 1. Okay, so this is how the cell number are named. Okay, this is how the cell number are named. So it will be, the answer here, it will be 3. This will be 2. Okay, this will be 4. This will be 5. This will be 7, and this will be 6. Okay, so let's put the value according to, let's put the mean term value. So first 1 is there, so let's put 1 here. Then 3. Okay, then 4, then 5, 6. Now you have to do the grouping, and I hope you know the rule for the grouping. Like you have to group the maximum possible subgroup. Okay, you have to cover the maximum possible subgroup in this. So as you can see that, let's consider for this one. So how this one we can cover? This one we can cover in this way. Like this we can do the grouping. You know the adjacent cell grouping. So this is how we have done the grouping. Okay. Then this is what we can do. And before finding essential prime implicant, first we have to find prime implicants. And what is prime implicants? That you have to make maximum possible group. Okay, you have to make the maximum possible grouping. So this is also one of the group which you can do. This is also one of the group which you can do. Okay, so this is the maximum possible grouping we did. Now we have to see the groups where at least one, okay, which is not in more than one group. Okay, at least one variable which is not in more than one group. So as you can see that this group, okay, so this one has covered by many, okay, many groups, this one has covered, but can you see that here this one is covered by single one? So this is the group we can consider as essential prime implicants. Okay, we can consider this, and this one, you can see this group. So this one is covered by multiple ones, and this one is also covered by multiple ones. So this is not our essential prime implicant. Okay, and here you can see that this one, so this group also has this group one has covered by multiple groups. Okay, this one has covered by multiple groups, so we will not consider this as essential prime implicant. And as you can see that this one, okay, so it has covered by this one has covered by multiple group, but this one has not covered by multiple groups, so we will consider it. Okay, so we have two groups, okay, which we will consider as our answer, which is essential prime implicants. Now let's write the expression for this group. So it will be A bar C. Okay, it will be A bar C. And what is the expression for this group? This group expression is A C bar. Okay, so what is our answer? Our answer is option A, which is A bar C and A C bar. So I hope you got the solution. Okay, so let's move on to the next question now. So let let the function x, y, and z. Okay, so we have a function which is x, y, z equals to. So what the expression is given to us? Okay, so this is the expression given. Be a switching function, which of the following is valid? Okay, now the option A is y bar x is prime implicant of f. B is xy is a mean term of f, and xy is an implicant of f, and D is Okay, so let f x y z. So the expression given here is x bar plus y bar z, okay, and plus x y. So this is the function given to us. So let's see this. So you are asking what is prime implicance. So you know what is prime implicant. So the prime implicant is, I hope you are there. I'm explaining this now. So prime implicant means, see, we have one group. Okay, we have one group like this, and here we have two values, like this is 1 and this is 1. And if this one is covered by maximum group, okay, this group is covered by many, but this one is not covered. Okay, it is covered by single one. In one group, two ones are there. Okay, and at least one is not covered by many group. This is called as essential prime implicant. Okay, so I can again give you one example, like this is 1 and this is 1. Okay, so here as you can see that this and this, okay, this like this, it is covered. So can we consider that this is essential prime implicant? No, we cannot consider. Why? Because we don't have at least one which is covered by a single group. Here all the ones are covered by multiple group. So this is not called as essential prime implicant. Okay. And one more doubt was that what is after fifth clock cycle? So let's see this. So after the fifth clock cycle, the value will be. So can you see that this will be 0. Okay, this will be 0, and so 0 will pass here. This one will be here. This 0 will be here, and this 0 will be here. So this is after fifth clock cycle. This is after fifth clock cycle. So I hope the doubts are clear. So let's move on to the question which we were discussing earlier. Okay, so this was the question. So which of the following is valid? So can you just solve and let me give me the answer in the comment section for this. So Rajveer, I hope the after fifth clock cycle, it is you have got the answer. So can you all give me the answer in the comment box? I am waiting for your answer. Yes, it will be right shift only. Basically, the shift register is meant to be for right shift operations only. Okay. So can you all answer this? So this is a kind of previous question which we discussed. Here also you can see that it is not in its canonical form. And what is canonical form? Canonical form means, see, the functions the function variables are given as x, y, z. Okay, so here it should be like here it should be all the variables should be present in each term. So this is called as one term, this is called as second term, this is called as third term. So can you see that all the function variables are present here? No, they are not. Why? Because here only x is present, y, z are missing. So this is not in its canonical form. So whether you have to check for these options like prime implicant and everything, you should first have converted this into its canonical form. So let's try to do that. Okay. So x bar. Let's leave the space for here. YZ. Okay. Plus x, and see, the order also you should maintain. The order also you should maintain that it should be like x, y, z. Okay. It should be x, y, z. like this. In the function, it is given as x, y, z. So likewise, you should maintain the order here. Okay. So it is x, y, z. Okay. Now here x is given, but let's maintain the order here also. So here x is given. Okay. Then y bar is given. Let's leave the space for z. Okay. Plus then it is x is given. Let's keep the space for y. Then z. Okay. Like this. Now here it is 0. So we have two spaces. So that means we have the space for two variables. So how many combinations we will have? We will have 0 0, 0 1, 1 0, 1 1. Like this combinations we will have, and this will be 0 0 0. Okay, and this will be 1 0, and here one space, so two combinations 0 and 1. So here 0 1. Okay, and here it will be x, for x it will be 1, here the space is 0 1, and here it is 1 and 1, and this will be 1. Okay, now let's find the mean term for this. So this is 0, this is 1, this is 2, this is 3, this one is 4, this one is 5, this one is again 5, this one is 7. Okay, so I hope you got the mean terms. Now let's make the K map. So again we have to make the K map like we did earlier. So here the function is xyz. So the K map will look like this. This is 1, this is 2, this is 3, and this is 4. So this is x, this is yz. This is cell number 0, cell number 1, cell number 3, cell number 2, cell number 4, cell number 5, cell number 7, cell number 6. Now let's put the values for here for this. So here the value will be there. Now on here, then 1 also we have. So let me write the mean terms. So f is equals to mean term values are 0, 1, 2, 3, 4, 5, and 7. So only one space is left, which is of 6. Okay. So this is, let's leave the space for 6. Okay. So this space is left. Now let's do the grouping for this. So we can make a group of this of 4, because maximum grouping we have to do to reduce the variables. Okay, why we do maximum grouping? So that we should reduce the variables. Okay, so that variables should be reduced. So what is the answer for this? This is x bar. And here also one more grouping. So as you know that this is 0, this is 1, this is 0 0, this is 0 1, this is 1 0, and this is 1 1. Okay, this is also grouping we can do. So total, okay, let me use different color. So I hope you all know that how to do the grouping. Okay, there should not be any doubt in the grouping part. Okay, so this is the grouping we did. Now let's write the equation for the group. So it will be, so this side will be 0, 1, it will get cancelled, and from here we will have y bar, okay, plus x bar we have, okay, plus, and the answer for this will be, so here it should be 1, 1, right? Here it is 1, 1 and 1, 0. Please keep this in mind that the order of the K map, okay, for three variables is 0, 0, 0, 1, 1, 1, 1, 0. This is the order you should follow. Yes, you are right, Rajveer. Yes, it is 1, 1 and 1, 0 in K map. That's where I got, okay. So, what will be the answer for this box? So, this box answer will be, the 0 and 1 get cancelled. So, it will be Z. Okay, it will be Z. Now, okay, so maximum grouping we did. Now let's see the option. So, can you say that y bar x is a prime implicant of f? So first of all, we haven't got any equation as y bar x. Okay, we just got y bar. Okay, we just got y bar. So how it can be a prime implicant? Okay, it's just not an implicant. Okay, we haven't got the expression, so how it can be a prime implicant? So that's why option A is false. Okay, that's why option A is false. Now let's see for the option B. So okay, so see for the option C. Now x y z. Okay, the option is y z. So yz is an implicant of f. So can we say that xz is an implicant of f? We can say that. Okay, we can say that. No, it is not implicant. It is mean term. Okay, just know the difference between implicant and mean term. Mean term is something like this. They are the mean terms. Okay, and implicant or prime implicant, which is related to grouping. Okay, which is related to grouping. So as you all see that, as you can see that xz is not an implicant of f, but it is mean term of f. Okay, it is mean term of f. If we didn't go for the grouping for maximum, okay, so what the expression we will get? X bar plus y bar x plus xz. Okay, so this is the answer for the maximum grouping. Okay, for the maximum possible grouping we did, so this is the expression we got. Okay, but let's not consider this grouping. Instead, we will do the grouping differently. So how to get this yz? Okay, sorry, this is xz. So from here x and z we will get like this. Like if we do the grouping of like this, so the answer here is, here we will get x, and here we will get, from this we will get z. So can you see that this is a mean term of f? Okay, so option so you, no, it is not mean term, but it is implicant of f. Okay, it is implicant of f. As you can see that if we make the grouping like this, so with this grouping, can we say that it is implicant of f xz? So we can say that it is implicant of f. Okay, so option C is correct here. Option B is false because xz is not a mean term. Okay, because mean term must include all variables. Whenever I say canonical form, so these are the mean terms we have taken. Okay, these are the mean terms we have considered. So can you see that we have considered all the variables while taking this mean terms? So likewise, when we will say that xz, we can't say that this is a mean term because here y is absent. Okay, so mean terms should always be in its canonical form. So we cannot say that xz is a mean term. Okay, so what is the mean terms example? For this function, it will be xyz, it will be x y bar z, something like that, which should have all its variable given in the function. Okay, and why option D is false? Because y is a prime implicant of f, but y bar is a y bar. Okay, y bar is prime implicant, not y. Okay, we haven't got this term, so how we can say that this is prime implicant? We can say for this also. So the reasoning for option A and option D is similar. Okay, option B is that this is not a mean term, so that's why option B is also false. Option C is correct. I hope you got with the solution. Okay, so let's move on to the next question now. So the question is, let R1 and R2 be two 4-bit registers that store number in its 2's complement form. For the operation R1 plus R2, okay, which of the following values of R1 and R2 gives an arithmetic overflow? So do you know some tricks about how to find out overflows? So let's discuss some tricks about it. Okay. So how to find out the overflow? If two numbers, let's first know the general definition of overflow. Okay. Then let's see this. Then we will finally see the options. Okay. So two numbers are represented using 2's complement, 2's complement n bits with n bits. Okay. So what is the overflow condition? So condition for overflow. Condition for overflow. So overflow occurs if the sign bit of the addends are the same and the sign bits of the sum is different from the addends sign. Okay. So step 1, different. Okay. Different. So let me give you an example. So this is A. Okay. And let's suppose say that we have this bits. Okay. And yes, Nishu, your option is correct. That option B is correct. Okay. Then this is B. Then this is S. So these are the some values here for B value also, for S value also. So what you have to check? So what is the first step to check this? Okay, to first check these two bits. Okay, we have to compare, and what these bits are called as sign bits of the addends. Okay, sign bits of the addends. Now we can have two possibilities here. First possibility is that they both are different. Okay, and the second possibility is that they both can be same. So if this two is different, if this two is different, then overflow never occurs, never occurs. So this is the trick. So please listen this carefully. Okay, it can solve your questions in second. You can solve the questions, such type of questions in second by using this trick. Okay, and if they are same, so may or may not occur, may or may not occur. So what is the first step? That what is the first step? That you have to check these bits. If they both are different, then definitely overflow will not occur. Okay, then you don't have to look for the next one. Okay, but if they both are same, then the next second step, so this is step 1. If they both are same, then we have to perform step 2. Okay, we have to perform step 2. Now let's say that same we have the bits, B also we have the bits, and after doing the sum, again we have the bits. So if this one, this two, and this one, okay, this two and this one. So if we compare both of them, if we compare both of them, so the answer can be, they can be same or they can be different. So they both are same. That's why we are taking it as one unit. And this. So now we are comparing that if this and this can be same or they both can be different. Okay. So let's write the result here. So if they are same, okay, so 1, 2, 3, if they are same, then no overflow. Okay, so let's write this again. So let's take our step 1 is A, B and sum. So 1, 2, 3, let's suppose we have this number 1, 2, 3, and the sum part also we have this number. So when they both are different, okay, when these bits are different, then no overflow. But when these bits are same, then may or may not be an overflow. May or may not be an overflow. Okay. So now, but here if they both are same, then this steps comes into the picture. Step 2. Okay. Step 2. So what is our step 2? A, B, S. Okay, so what is the step 2? So let's take that we have some bits here. Okay, these are the bits. Now they both are same. Okay, this one and this one. Now they both are same, so no overflow, no overflow. Okay, and they both are different, then overflow, then overflow. Okay, so this is the trick. So while explaining, this got a lot of time, but trust me, like if you know this trick, then you can easily get the answers in second. Now let's compare this with option. What they are basically asking us for the overflow. Okay, they are basically asking us for the overflow. Now let's check this one by one. So can you see that they both are same? So we have to go for the step 2. Okay, and here also you can see that. So in every case, all are same. So we have to go for step 2. Okay, so let's add them. So let's add, let's see option A. So R1, R1 is equals to 1011, R2 is equals to 1110. Okay, what is the sum? This is 1. 1 0 1 0 1, this one and here. Okay, so as you can see that when they all are same, this one, this one and this one, when they all are same, okay, when they all are same, then we can say that this is not an overflow. Okay, this is not an overflow. So this is not an overflow, that's why option A is incorrect. Let's see for the option B. Okay, so R1 is equals to 1100. Okay, R2 is equals to 1010. Okay, so let's add them. So this is 0, this is 1, this is 1, and here this is 0 and this is 1. So can you see that these two bits, okay, and this bits, they both are different. So when they both are different, then overflow occurs, and what we want, overflow. So that's why option B is correct. Now let's similarly check for the option C. Let's check here. So this is R1 is equals to 0011. Okay, R2 is equals to 0100. So this is 1, this is 1, this is 1, and this is 0. So as you can see that these bits are same and this bits also same. So I have told you the condition that when they both are same, that no overflow occurs. Okay, no overflow occurs. So option C is also incorrect. Now let's see the option D. So 1 0 0 1 and 1 1 1 1. So this is 0, this is 1, this is 0, this is 1, this is 0, this is 1. So this is 1 and this is 1. As you can see that they both are same. Okay, so that's why also no overflow. So only option B is there where overflow occurs. Okay, so please note down this 2 steps. This is very essential. Okay. Yes, Nishu, you are absolutely correct. Okay, you gave the answer so early. So I thought, okay, so let's move the. Now this is the next question. Consider three floating numbers, okay, A, B and C, stored in register RA, RB, RC respectively, as per IEEE 754 single precision floating point format. The 32-bit content stored in these registers in hexadecimal form are as follows. So this is RA, this is RB, this is RC. Okay, which one of the following is false? So can you just try to solve by yourself? Yes, Nishu, this is also one of the trick to solve the problem. You are absolutely correct. But the more modified way I thought that you should know. So that's why the another method also I discussed in the question. But yours is also right. Okay. So I'm giving you some time. Okay. For this question, please try to solve it by yourself and let me give you the answer afterwards. So we have basically two methods for this. Okay. So let's discuss our method 1. So what is IEEE 754 single precision? So do you all know the representation for this? So IEEE 754 single precision. Yes, sign bit is one issue. But what about the exponent and mantissa? So representation. Yes, absolutely correct. The exponent is 8 and the mantissa is 23, right? Representation. Okay. Yes, the mantissa is 23, correct. So sign 1 for sign bit, 8 exponent bit, and 23 mantissa bit. And do you all know the formula, like how to convert this into the decimal value? So let me give you the formula. So decimal value, decimal value equals to 1 minus sign bit 1 minus sign bit into 1 dot mantissa. So 1 dot mantissa into 2 into exponent minus 127. Yes. Yes, correct, Nishu. Yes. And the base is 127 for single precision and double precision is 1023. Yes, yes. Correct. Now let's convert it. Okay. So RE is given to us. Okay, so let's consider this RA. So this OX basically represents hexadecimal. Okay, so this is not any value. The value starts from C14 and this C is represented in 4 bit. 1 is represented in 4 bit, 4 is represented in 4 bit. Okay, so this 0x is the hexadecimal sign. Whenever you will see the 0x, this is not any number. Okay, this is the representation that this is like expression. Okay, so this number is represented in hexadecimal. Okay, so how we can write C14 and this all these zeros? So C can be written as 1100. Okay, 1 can be written as 0001. Okay, and how 4 can be represented? So it is 01000. Okay, and rest all are zeros. So don't look up to 0. Yes, each hexadecimal digit represented in 4 bit. Absolutely correct. Yes, and Nishu, from 0 to 9 it is in numerical form, and after that A to F it is in alphabetical form. Okay, so this is reserved as sign bit. Okay, this is reserved as sign bit, and 8 bit for the exponent part. So from here 1 2 3 4 5 6 7 8. So this is for the exponent part. Okay, exponent part, and rest are for the Mentisa part. Okay, so rest are for the Mentisa part. And how many Mentisa part? 23. Okay, so let's write this in a number. So RA is equals to minus 1 to the power 1. Okay, into, so this number is 130. Okay, if you will, so this is the binary form. If you will convert this number into decimal form, so it will be 130. Okay, then so 1 dot 100. Okay, 1 dot, so up to here it should be, so this is 1, this is 100, then 30 it should have. Okay, so this is 100, and then after that 1 2 3 zeros, 1, and again 10 should be there because of 4. Here 1 should be have. Okay, so it will be 1000. Okay, up to 23, into, now the exponent part. So 2 into 130 is our exponent, minus 127. So what is the value we are getting? The value is minus 1100 base 2. And if we will convert this base into decimal, so it will be minus 12. Yes, Nishu, absolutely correct. The base is minus 12. Now similarly try to do for RB. Okay, so let's try to do for RB, but first you should do it and then check the answer that whether you are correct or not. RB. Okay, so first value is given as 4. So 4 can be represented as 0 1 0 0. Okay, then how 2 is represented? 0 0 1 0. How 1 is represented? 0 0 0 1. Okay, and rest all zeros, 1, 2, 3, 4. Okay, all the zeros are also represented in 4 bits. So this zeros will cover 1, 2, 3, 4, 5. 5 fours are 20. Okay, so this 0 will cover rest 20 bits. That we don't have to consider because it will be covered in Mantissa part. Okay, so that's why I'm leaving the 0. Now this one is for the sign bit. So it will be, and this 8 bits will be for the, for what it will be 8 bits? Okay, for the exponent it will be. Yes, yes. MSQ, are you talking about MSQ? Yes. The question can come, but solving such questions in MSQ, it will go too lengthy. Okay, so either it will be come from MSQ only, because MCQ, you have to solve it for all, and such type of question will make it lengthy. So that's why I don't think that this will come for MSQ. Okay, or by solving the steps, if you know some of the results, then they can give you as MSQ. Otherwise, MCQs are possible. So here -1, the sign bit here is 0. Now here the exponent will be 1, 2, 3, 4, 5, 6, 7, 8. So up to here, exponents will be there. And from here, we will have the Mantissa part. Okay. So the exponent here will be 1 dot, 1 dot, the Mantissa 0, 0, 1, 0, 0, 0, and so on. What is the exponent? If you have calculated what is the exponent, it is 132 into 2. So 132 minus 127. Yeah, yes, correct. So it is 9. Okay. It is not 9. It is 132 minus 127. Okay. So what the answer will be here? It will be minus 1,0,0,1,0,0,2. Okay. So base is 2. So the answer is 36. The answer is 36. So A answer is okay. So let me share the screen. Sorry, I got disconnected because of network issue. Okay. Perfect. Okay. So what are the answers we got here? So for RA, the value is -12. RB, okay. For RB, the value is 36. The value is 36. Now, can you similarly calculate the value for RC? Okay. Now I have calculated RA and RB. Now, can you calculate similarly the value for RC as well? Yes, Nishu. The value for RC is 12. Okay, absolutely correct. The value for RC is 12. Now, what is the correct answer? Okay, so they are asking for the false result. Okay, they are asking us for the false result. So so full screen is visible to you all or not? So the screen is visible properly? Yes, wait, that's what I am doing. Like, why this full screen is not visible? Is it visible now? I hope it is visible. Okay, so let's start it. Okay, so what was our answer? For RA, it was minus 12. For RB, it is 36. Am I all visible to you? Please write in the chat box. Am I visible? Okay. Yes, now I guess it is visible. Okay. So what is the value of RA? So let's take the option one by one. So A plus C. So this is our A plus C. So we are getting the correct answer, which is A is correct, but this is not our answer because we want the false answer. Okay. With something. Okay, so value we have for, can you just quickly tell me what is the value we have for A, B and C? I'm so sorry, because of network issue it is happening. Okay, so just quickly check the options. So A value is -12, B value is 36, C value is 12. So option A, if we will check that, it will be 0, but this is correct actually, but we want the false one. So that's why this is not our answer. If we will check for option C, so 12 is equals to, okay, B and C they are saying, so 36 minus 12. What is the answer for 36 minus 12? So it is 24. So 12 is not equals to 24. So this this is our answer. Okay. Now let's check for B is equals to C. So yes, it is also correct, because 12 threes are 36. So this is not our answer. And B minus C. So B minus C, if we will do, so yes, it is also greater than 0. So that's why this is not our answer. So Nisho is absolutely correct that A, C and D is true and B is false. Okay, B is false. Now let's move on to next question. Okay, let's move on to next question now. So can you just solve this? So what is this O here? This O is octal. Okay, this is in octal form. This is in hexadecimal form and this is in binary form. Okay, so this is what it means. So can we just do the subtraction as it is? No. First we have to convert either this into the binary form or this into the hexadecimal form. Then only we can do the subtraction, and we have to get the answer into the octal form. Okay, so this is the conversion. Okay, we have to do. So let's solve the question. So do you all know the basics of binary subtraction? Like I'll tell you, 0 minus 0 is always 0. Okay, and 1 minus 1 is always 0. 1 minus 0 is 1. Okay, and 0 minus 1 is 1, and 1 is in borrow. 1 borrow. Okay, so this is the binary subtraction. Okay, now let's convert this into the binary form. This is already in binary form. Let's subtract them, and we will easily we can convert this into the octal form by taking 3 bits. As you all know that if the binary form is given, we have to convert it into octal form. So what we do, we just group it by 3. Okay, from here we just start to grouping, and after decimal we start grouping this way. And if we have to do in hexadecimal form, then we make a group of 4. Why in octal we make a group of 3, and why in hexadecimal we make a group of 4? Because octal is represented 2 to the power 3, okay, and hexadecimal is 2 to the power 4. In octal we always have representation in 3 bits, okay, so that's why 3 grouping we do, grouping of 3. And hexadecimal, it is represented by 2 to the power 4. Okay, 2 to the power 4. So that's why, okay, that's why it is that's why the grouping is done in 4 bits. Okay, so let's try to convert this hexadecimal into the binary. It is very easy how C is represented in binary. So let's write it. Yes, absolutely correct, Nishu. So C is represented as 1 1 0 0. Okay, 0 is represented as 1 2 3 4. Okay, this one is represented as 1 2 3 1 and 1, and this 2 is represented as 0 0 1 0. Dot, Again represent this 2, so it is 0, 0, 1, 0. Okay, and this 5 will be represented as 0, 1, 0, 1. Okay, now let's do the subtraction. So let's put the value here from this side. Okay, so this is dot. Now look carefully. Now we are we are putting the value here 0, 1, 0, 1, and rest of the place we will fill with 0. Okay, rest of the place we will fill with 0. So 1, 2, 3, 4, 5. Okay, this you have to do. Now you have to start filling the binary digits from this place. So it will be 0, this is 1. So how many times 1? 3 times 1. So let's fill it 1, 2, 3. Okay, then again 2 zeros, then again 1, 2, 3. Okay, then 0, 1, and rest all you have to fill with zeros. So you know the technique, like how to do this. Okay, so this is the method that you should perform, okay, while doing the subtraction. Now what is the result for subtraction? So the result is 1, 0, 1, 1. Okay, 1, 0, 1, then 0, 0, 1, 0, 0, 0, 0, 1, 1, decimal point, then 1, 0, 0, 0, 0, 1, 0, 1, 0. So this is the binary subtraction rule. So likewise, I subtracted this number with this number and we got the result. Okay, now let's make the pair of 3. Okay, and we will get the octal form. So let's make the grouping of 3 here. So this is group 1. Okay, this is group 2. This is group 3. This is after decimal. Okay, before decimal, this is the group. This is the group. This one, and this one. And this one is left, so we'll write the zeros here. Okay, and we have got the group of 3. So what is our answer? Let's write the answer here. So this is 1. This is 1. This is 3. This is 5. This is 1 again. This is 0. This is 3. Point. This is 4. This is 1. This is 2. This is 1 and this is 2. Yeah, from binary point, what do you mean by binary point we will subtract, Nishu? Like I'm not clear about your question. Like we will do point to point subtraction. Are you asking like how to subtract? Like see, I'll tell you like this. See, this is 1, 0. So what is the result of 1, 0? It is so if you can see that 1, 0, the result here is 1. Okay, we will do the subtraction this way. Like this we will do subtraction. Like this is 0, 1. Okay, so the what is the result of 0, 1? 1 and the borrow 1 here. Okay, again we will take the borrow and we will solve it similarly. Okay, so this is point to point subtraction we have to do. Like this is 0, 0. Okay, this is 1, 1. So the answer is 0. So this is how you have to perform the subtraction. I hope it is clear. So what is our answer? Our answer is option A. Okay, our answer is option A. Now let's move on to next. Okay, now you all can quickly give me the result. like which has overflow or not. So I expect from you that you should answer this correctly. Please give me answer in the chat box. So here 1, 1, 0, 1. This is 0, 1, 0, 0. They are asking us for the addition. So this is 1, 0, 0, 1, 0, 1. So what is the answer for this? Answer for this is the answer. What is our first step? Our first step is that if we see this as different, then definitely no overflow. We don't have to go for the step 2. Simply no overflow. By seeing this 2 bit, if they are different, then we can say that no overflow directly. So no overflow is the answer, but no overflow is also here. Okay, but we did the addition, so the result we got is this. So that's why option C is correct. Okay, earlier I took some time to explain you. Okay, that's why it got so long, but you can see here in seconds we just marked the answer. Okay, so you should know the trick. No, option C is correct for this. Which question are you talking about? Option C is correct. Okay, have you got like why the option C is correct, why A is not correct, how it can be an overflow? See, I mentioned you the steps. Okay, so here, can you see here? Can you see all here? Like different, if in the step 1 itself, if they both are different, then no overflow. We don't have to go for options, we don't have to go for step 2. Okay, because it is no overflow. So here itself, the answer is C. So we will have confusion in B and C because no overflow is given in both. But with this result, it is very much sure that our answer C is correct. Yes, very good. Let's move on to next. Okay. Can you evaluate this, the multiplication? So let's try to solve the question. So this is in octal form. This is also in octal form. And the result also we want in octal form. But can we just convert this into decimal form? This also in decimal form. The result whatever we will get, that will be in decimal form, and later we can convert it into octal form. Can we just do that and get the answer? So let's solve the step 1. So let's convert 34.4 octal to decimal. How to do it? So 3 into 8 to the power 1 plus 4 into 8 square, okay, plus 4 into 8 to the power 0. Okay, no. Wait, yes. 4 into 8 to the power 0 plus 3 into 8 to the power 1 plus 4 into 8 to the power minus 1. No, yeah, I mean, see, directly if you will multiply, right? So this is not something which is in uh, like octal form. It is in octal form. Okay, so just try to simply multiply it. What is the result you can get? Just see that. So if you will do the multiplication directly, the answer is coming 4804.96, and here no option is present. Okay, why we can't do direct multiplication? Because it is not in decimal form. Okay, if we will do direct multiplication, this is the result we are getting, and it is not in decimal form. So for that we have to convert first it into decimal form, and then we will do the multiplication. Yeah, we have to do mod of 8. Yes, because here if the base is 8, then here it should be smaller than 8, every value. So try to solve this, like 34 into 23, 4. So 4 4s are 16. Okay, mod 8. So like this. So try to solve this way. If you are getting the answer, let me know. So the answer here will be 0. Nisha, you are actually correct. Yes, absolutely correct. Yes, we can avoid the conversion here. We can simply do the multiplication. Okay, and whenever we find that our result is greater than 8, we just simply do mod. Okay, we can just simply do mod. Okay, so how it will be, like 4 and 4, it will be 16, and 16 mod. Okay, 8 mod 16 will be 0. Then after we will do 12. Okay, if we 4 4 is 16 again. So okay, we can perform this way. So it will be 162, and then it will be 1254. This will be 710. And if we do the addition of this, okay, so in addition part also you have to take care of the mod. So this will be 6, this will be 11. 11 mod, okay, 11 mod 8 is 3, and carry forward the 1 here, 2, 5. Okay, yes, option A is correct. Option A is correct. But have you got like the short form of this, like without conversion, how you can do this? So this will be 105. Okay, and after 2, like after 2 places decimal is there, so we'll put the decimal like this. Okay, so this is also a better option. Okay, so the students who cannot do without conversion, okay, the one who finds this difficult, they can do with conversion also. Yes, so let's try this for Vijay. Okay, so let's try the conversion part for Vijay. So as we were converting this, okay, so what is the answer for this? The answer is 24 plus 4 plus 0.5, and it will be 28.5 decimal value. Okay, so this value we converted into the decimal form, Now it's time for this one. So let's do it. So 23.4 base 8. Okay, let's try to convert this into the decimal form. So this will be 2 into 8 1 plus 3 into 8 to the power 0 plus 4 into 8 to the power minus 1. So this will be 16 plus 3 plus 0 0.5, 19.5, and the base is decimal. Okay, now this is the value we got, and this also. And if you will do simply multiplication, so the answer we will get is 555.75, and the base is 10. Now you have to convert it into the the octal form. So the integer part, how we will do? So just see here, 555.8, it will be 69, and the remainder will be 3. This will be 8. This will be 1. The remainder will be 5. This will be 8. It will be 1, and here it will be 0, and we will go in this direction. So what the for the decimal part, for the integer part, what is the answer we are getting? It is 1053. Are we getting this value? 1053. Okay. So this is for the students who find it difficult to directly do the without doing the conversion. Okay. So for that, for them I am doing the conversion. Okay. And how to solve this integral part? Sorry, decimal part. So we simply have to multiply 0.75 into 8. The answer is 6.0. Okay, so we will keep this 6. And yes, here we converted this into octal form, and option A is correct. I hope this question is clear. If you are having any doubt, please ask. Okay, let's move on to the next. Can you convert this? The number, this is an octal form, is equivalent to 16 and the 4 is given. This is very easy question. Okay, like how? I'll tell you. First convert each this number into binary form. So let's try to convert. So 1 is represented as 001, 2 is represented as 010, 3 is represented as 011, 4 is represented as 100, 5 is represented as 011. Okay, and what is CC, Vijay? Then 6 is represented as 110. Okay, now let's try to do the grouping. So this is 16, so this is 2 to the power 4. This is 4, so this is 2 to the power 2. So this tells do the grouping of 4, and this 4 tells do the grouping of 2. So let's try to first do the grouping of 4, then we will see the grouping of 2. Okay, so let's see this. So from here, from right hand side, we will do the grouping. We always do the grouping from right hand side. And for the decimal, we always do it for the left hand side. Okay, this should be clear. So 1, 2, 3, 4. This is one group. 1, 2, 3, 4. This is other group. 1, 2, 3, 4. Okay. And 1, 2, 3, 4. And here the values are left, so we can add 0, 0 here. Okay. Now let's get the values. So the answer here is, answer for this is 0. Answer for this group is 10, which is A. Okay, which is A. Answer for this group is 7. This one is 2. And this one is E. So what is the answer? So can we consider, do we have to consider this 0? No, because 0, 2 is equals to 2 also. Okay, so that's why additionally we are not adding 0 here. So what is our answer? Our answer is A, 7, 2, E. Now let's eliminate the option. Okay, so A, 7, 2, E. So this and this, option C and option D, we eliminated. Okay, now with the grouping of 2, we can know that which of them are correct. Okay, so here itself, we will erase this and we will start to make group of 2 now. Because we want, for the base 4 we want, right? This was our original numbers. Okay, original representation in binary. So let's try to group them with 4, group them with 2. Why we are doing the grouping with 2 only? Because here 4, which we can represent it as 2 to the power 2. And here this power represents that whatever bit we have to take in grouping. Okay, yes, it can be either A or B. Let's see like which is the correct one. So this is one group, this is the other group, this one, this one, this one, this one. Okay, yes. Now let's represent it, let's represent this into decimal form. So this is 0. What we can say, this is 2, right? This is also 2. This is 1. This is 3. This is 0. This is 2. This is 3. This is 2. Okay. So which one is the correct? Now can you get the clear picture? Like which one is the correct one? So we can write this as 2, 2, 1, 3, 0, 2, 3, 2. Okay. So which one is the correct? Option A is the correct and option B is false. So I hope this is very well clear to you. Okay, let's move on to the next question now. Yes, if x and y are two decimal digits and 0.1101, this is in decimal form, 0.8 xy 5 and the base is 10. Okay, base 10 is given here. The decimal value of x plus y is. Now we don't know the decimal value of x and y. So we have to find it out. Okay. So can you just think about the approach yourself first? Okay. Then I'll tell you the answer. So can you see that they both, it is saying that they both are equal. Can you get some hint from this? Like if we do some conversion here, okay, if we convert this to with the decimal form, so if we will compare this value, we can get the value of x and y. Okay, this is one hint. Yes, absolutely correct. Binary to decimal. Let's try to do this. Let's try to do the conversion now. Okay. So here this, okay, so this will be 0 into 2 to the power 0 plus 1 into 2 to the power minus 1 plus 1 into 2 to the power minus 2 plus 0 into 2 to the power minus 3 plus 1 into 2 to the power minus 4. So here this will be 0 plus 1 by 2. Okay, and it will be 1 by 4. This will be 0 plus this will be 1 by 16. So what is the LCM of this? LCM will be 16. Okay, the answer here will be 8 plus 4 plus 1, which will be 13 divided by 16. And if you will do the division of this, what is the answer? 0.8125. So in which form is this? This is in decimal form. and this is also in decimal form. So can we equate them? Because for the equation, we just want our base to be same. So the base of both of them are same. So can we just equate them now? So 0.8 xy5. So x value is 1 and y value will be 2. So x value is equals to 1, y value equals to 2. What is the answer? The answer is 3. Yes, absolutely correct, Nishu. The answer is 3. Okay, this was a little bit easy kind of question when you got to know this hint. Okay, if you understood this hint, then the question is easy. Okay. So this is our next question. Try to solve this. Consider z is equals to x minus y, where x, y, z are all in sign magnitude form. Okay. X and y each represent in n bits. To avoid overflow, the representation of z would require a minimum of how many bits are required? Okay, how many bits are required? What will be the answer? No, option B is not correct. N is also not correct. Okay, so I'll explain you this question. Just see carefully now. Okay. Overflow, when you can say that overflow can occur? Yes, absolutely. Option C is correct. N plus 1. But let me give you the reasoning for this. Okay. Now, when we can say that overflow can occur, when two same sign numbers are there in the added form, okay, in the addend, if two numbers are same, okay, and the resultant is also same, we can say that it is overflow. So for that, let's take one example here. N is equals to 4. Okay, our n is of 4 bit. Let's say x value is plus 6 and y value is minus 5. Okay, let's consider this two number. So 1 bit is for sign and 3 bit is for magnitude. Can you just see that? 1, 2, 3, 4. So this bit is for sign and this bit is for magnitude. Okay, it will be for magnitude. Now z equals to what they are saying, x minus y. So x is plus 6, y is minus of minus 5. So this is originally they have given in the question and the y value is minus 5. So what is the answer? The answer is 6 plus, the answer is 6 plus 5, it is 11. Okay, 11 is the answer. Now, how many bits are required to store this 11? Can you just tell me? Like originally we have taken 4 bit, 1 bit for sign, 3 bit for magnitude. We represented our 6, how we represented it? Sign bit 0. And how to represent 6? 1, 1, 0. This is our plus 6. How we represented it? Minus 5. Here 1 for the sign bit, and how to represent 5? Like this. Now how to represent 11? Oh yes, 5 bits are required. Okay, 5 bits are required to represent 11. And how the 5 bits? For the sign bit. Okay, 1 bit needed for the sign. So 4 plus 1. 4 bit to store 11 and 1 bit for sign. 1 bit for sign. And can we overcome overflow for this from this? Okay, can we avoid overflow also? So if this is n, so what is the answer? N plus 1 bits are required. Okay, n plus 1 bits are required. So therefore, to avoid overflow, the representation of z would require a minimum of n plus 1 bits. Clear everyone with this question? Okay. So this will be 1, 2, 3, 4. And here the weightage will be 8, 4, 2, 1. So to make it 11, it will be 1 here. This will be 0, this will be 1, this will be 1. So here we represented it 11. But again, we need for the sign bit. So again, we are adding one more bit. So how many it will be? 1, 2, 3, 4, 5. Originally, we have taken 4 bit. But to store this value, we need one more bit. So what is the answer? Option C is correct. The answer is n plus 1 bits. Okay, in the question, if you have some confusion, so you can take such examples and you can just check the answer. You can substitute some value like as I have taken plus 6 and minus 5. You can take the value likewise, okay, and you can check the answer. Okay, you can evaluate the answer. Okay, so I hope this question is clear. Let's move on to the next question. In 16-bit 2's complement representation, the decimal number minus 28 is. This is very easy question. Can you just give me the answer in the chat box? How minus 28 is represented in 16-bit 2's complement? For that we have to take out how plus 28 is represented. Okay, how plus 28 is represented? 16-bit. So originally how to represent 28? So it will be 1, 2, 3, 1, 1, 1, 0, 0. This is the way to represent plus 28. But we want 16 bits. So how many? So we have to add some bits, and only on this side we can add. So 1, 2, 3, 4. 1, 2, 3, 4 bits, bits which are needed to be added. Okay, because here this is represented in 8 bit. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. This is 28. But here they are asking us for 16 bit. So additionally we have to do the sign extension. Sorry, it is bit extension. And in the positive, how the bit extension is done? By adding zeros to it. So we added again 8 bit to make it a 16 bit. Okay. Now what we will do? We will do just the complement of this. So let's try to do the complement. So this will be 1, 2, 3, 4, 1, 2, 3, 4. This will be 1, 1, 1, 1, 2, 3, and this will be 1 and 1. Plus 1 we will add here. Okay. So this is 0, 1, 0, 1, 1. This is 0, 0. This is 1, 1, 1. Okay. And this is 1, 1, 1, 1 here. This is 1, 1, 1, 1. Okay. So which is matching with the option? Can you see option A is matching? So with the last 4 bits, can you check that? Are we matching option A? No. So option A is cancelled. B is matching. Yes, it is matching. So, but see, with the last 4, it is matching. But can you see the first 4? In our answer, it is all 1. So that's why option B is also incorrect. Option C, if you can see that everything is matching. So that's why option C is correct and option D is false. Okay. So I hope this is clear. Let's move on to next. So this is a similar kind of question. Now I can, I hope you can easily solve this now. The 16-bit 2's complement representation of an integer, this is provided, okay. Its decimal representation is, so I have one trick for you for to solve such type of questions. See, whenever after so many ones, if a single zero comes, we have to stop there, and up to there only we have to convert that into decimal form. Like this all ones we have to avoid, okay. So avoid this all ones, and we just have to stop there where we are getting the first zero, and we will check the result for that. Let's see this. So here no zero is coming, so we will carry forward this like this, okay. Zero is not coming, so here zero came, first zero came, so just stop it. Take this one, and up to here now only calculate this, okay. Calculate the decimal equivalent form only for this. And as they are saying that this is 2's complement and the sign bit is also 1, so it is minus, obviously, okay. Minus of 1 0 1 0 1. What is the answer for this? Okay, so from this you have to consider after the 1, okay, after the 1 values you have to consider. So what is the answer? Yes, absolutely. It will come into the minus part. So that's why we are not considering it. So if we see like the weightage wise, so this will be, this has 1 weight, 2, 4, 8, and the weight for this will be 16. Are we doing anything wrong here? No, we are not doing anything wrong, because this will be in the minus part, okay. Like minus 16 plus 4 plus 1, okay. It will be like that. So yeah, it is, I have written same, right? Okay, am I doing any mistake? No, it's not a mistake. See, this one, this we will consider as minus 16. This we will consider as 4, and this we will consider as 1. Okay, so minus 16 plus 5 will be minus 11. Okay, so what is the answer? The answer is minus 11. Have you all got this? Like how I did directly? Or should I explain you the steps? Yes, absolutely, Jay. So this is a kind of trick. So what is the trick? I'll again explain you. This is very this trick is very time saving. Okay, I'll again explain you if you have learned something new. So look, so up to 1, so we have to skip all the ones up till we get the first 0. Okay, so here we got the first 0, so this bit, this one, and up to here we have to consider, not wait. LHS to RHS. Nisha, I'm not getting you. So here from this one to this, okay. So from this one you have to consider up till here, up till the last. And this one you have to take it as minus. Okay, this one you have to take it as minus. So this is minus 2 to the power 4. plus this you have to take minus 2 to the power 3. 0 into minus 2 to the power 3 plus this one minus 2 to the power 2 plus 0 into minus 2 to the power 1 plus 1 into minus 2 to the power 0. So what is the answer? Minus 16 plus 4 plus 1. So the answer is minus 11. Got this? Yes, that is also the way to do it, Jay. But this is also one of the way which you can do. Okay, you can consider this bit as the minus sign and rest you can do like the normal addition. Nishu is absolutely correct. He is saying that we will traverse from least significant bit. We will skip zeros till first one, and after one encounter we will flip bits. Yes, so this is what Jay is saying, right? Or you can also do this way without the flip and all. You can just consider this bit as minus to the powers whatever it is, and rest you can do the addition. Okay, this is also one of the way which you can do. Yes, okay, okay. So let's solve this question. Can you just solve this question? Consider the equation 43 and we have to get the base. Okay, here for y we have to get the value. So where x and y are unknown, okay, the number of possible solutions is. So what are the possible solutions which we will get here? So here the largest value is 4. Okay, okay, yes, you just simply converted the base, right, Nishu? Like 4x plus 3 you are writing, which is base 10, and 8y plus 3 you are writing with the base 10. Okay, first you just converted the base to 10, okay, to the decimal base, and we get the equation which is x equals to 2y. Yes, absolutely correct, Nishu. Like first let's try to convert this into the decimal base, this also into the decimal base. So the answer we are getting is 4x plus 3 equals to 8y plus 3. Okay, so how we did this? So it is 4 into x plus 3 into x to the power 0 equals to 8 into y plus 8 to the power 0 into 3. Okay, and here we can say that x is equals to 2y. And if we will put, so what are the constraint here? That x should be strictly greater than 5. Why? Because the greatest value here is 4 and y should be strictly smaller than 8, because here the bracket inside it should be smaller than the base. Yes, it should be greater equals to 5. Okay, can we write like this, like x is greater than equals to 5? Can we write this way? Okay, x yes, the possible values are 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. Yes, absolutely correct. So how many pairs are they? Are they 5 pairs? Yes, 5 pairs are there. There are 5 pairs. Yes, 5 solutions possible. Absolutely correct. Okay, let's move on to the next question. You guys are doing really very well. Like this is like the last one, okay, of the exam, but your answers are absolutely correct. You know, this is purely the marathon for like practice, but you guys are really doing so well. Okay, so let's try to solve this question. So let R denote the number system radix The only values of r that satisfy the equation. Okay. So for such type of question, what we will do, we will just do the squaring. Okay. For such type of question, the methods are like fixed. Like for such type of question, we will first do the squaring like this. So it will be 1 to 1 r, and this will be 1 to 1 r. Any value of 2. Absolutely correct, Jay. The answer is correct. It is the option D. Can you just write the reasoning why the answer is D? Okay, because see, after this step, yes, Nisho, absolutely correct. The answer is D. Like here, if we will do the conversion, okay, so 1 plus r is equals to 1 plus r we are getting. Okay, so any integer r satisfies this, but it should be greater than 2. Okay, but it should be greater than 2, because here itself in the bracket the largest value possible is 2. Okay, and it should be greater than 2. What you are saying, Vijay? What same number? Yeah, 1 to 1 is square root. Yes, yes, absolutely. So this will be the answer. 1 plus r equals to 1 plus r. Okay, and why we are saying that it should be greater than 2? Any value should be greater than 2. Yes, because here if we will do 1 1, okay, so this should be greater than 2. The base should be greater than 2. Here if it is 2, then all the values inside this should be less than 2. Yes, absolutely correct. Okay, so I hope you got this. So what is the answer for this question? It is option D. Option D. Okay, let's move on to the next. So this is like a very easy question. Just tell me the answer in the chat box. Option A. Yes, correct. Option A is correct. So please keep remember, like for 2's complement, okay, the ranges from sign magnitude, okay, sign integer, unsigned integer, 1's complement, 2's complement, the ranges should be clear, okay, because such type of questions can come for 1 mark directly. Jay, I covered just one question of floating point representation, okay, and that one question has like for 3 values I have calculated, and for fixed format, like for single precision only I covered. For sign and 1's complement, it will be option B. Yes. So you want me to write the range for signed integer, unsigned integer, and 1's complement, 2's complement, or should I move to the next question? Okay, I can write the ranges also if you want, or I will move to the next question. Okay. So can you see the question? Convert the following number in the given basis into their equivalents in the desired basis. See, in the whole marathon, I have taken all the previous year questions, because previous year questions can make your base strong for the exam. Okay, and all the questions will come directly from the previous year itself. So it is very important for you to solve the previous year in single precision. Okay, so Jay, I will consider that, but now the time is literally, we have just 10 minutes left. Jay, it will require at least up to 15-20 minutes, okay, to explain. I'm really very sorry, but we just have 10 minutes. Like if you had asked me earlier in the session, like we had 2.5 hours session. Okay, so in that if you had asked, so I would have told, but now really the time is very less. I'm so sorry about it. Okay, can you get me the answer for this question? What is the answer for this? So 6.75, the value is for A, Nisha? No, it is wrong, Nishu. Like 6 is correct, the integer part is correct, but there is something wrong with the decimal part. So how it will be? It will be 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2 plus 1 into 2 to the power minus 1 plus 0 into 2 to the power minus 2 plus 1 into 2 to the power minus 3. So this will be 4 plus 2 plus 0, 1 by 2 plus 0, 1 by 8. 6 plus 1 by 2, 8. So this will be 6.625. Yes, Jay, absolutely correct. Vijay, you should be more precise with the decimal. Okay, in exam they will specify you like how many decimal digits they want. You have to write like way. Okay. So when I was attempting the question, right, one of my friend, they were asking for three decimal digits. Okay, 3 decimal digits they were asking, and my friend got 4 decimal digits, and he simply write 4 decimal digits and he make his answer wrong. His answer was more precise, but still they rejected that. So this is the learning which you can take, that whatever the decimal digits they have specified, you just write up to that. Don't write even more. Okay, one single digit also don't write more. Just write up to that. 3 they are asking, just write 3. 4 they are asking, just write 4. Yes, yes. We will do the division by 16. Absolutely correct, Nishu. And this is the integer part only, so it is like this you will do. 1118 divided by 16, so this will be 69, remainder will be 14. This will be 16, so it will be 4, this will be 5, and like this you will consider. So the answer is 4, 5, 14. So which will be 4, 5, E. J is correct, absolutely correct. Vijay, please be more precise with the answer, okay? Because eventually it will lose your marks. That's why I'm saying. Absolutely correct, Nishu. This is 4, 5, E. Yes. So the answer for this is 6.25, 625, and for this is 4, 5, E. Yes. So can you just solve this question? This is the last question of our class. The mux question. So what we can take here, x1a plus x1 bar b. This is the output we will go. Okay. Let's consider the output as y1. Okay. So it will be y1 x3 plus x3 bar x2. Yes, absolutely. So what will be the answer? So let's put the value of y1 here. So x1a plus x1 bar b, x3 plus x3 bar x2. Can you get the answer? Or you can simply just do by putting the option. Okay, this is also one of the way which you can do. Just put the answer and the output for the final one is AB. We have to get the values so that we should get the output as AB. Okay. Yes, Ajay, option A is correct. Option A is correct, Jay. We have to get AB. Yeah, this is AND, right? So what is x1 value? X1 value is B. X2 value is 0. X3 value is A. And what is the output? F is equals to AB. Okay. By putting the options also, you can get the answer. Do you have any general doubts? Because only 2 minutes are left to end the session. So you can ask me related to preparation or something like that if I can guide you. Aptitude part just cover what are the most asked topic. Okay, you can just prepare for that, and you can just means get the weightage out of each chapter and just prepare. Or you can also do PYQs, but PYQs is very much, right? So just from the YouTube lecture also you can see some of the parts, essential parts of aptitude, and you can go like that. Yes, you can ask Nishu, what is your question? Okay, one more question are you saying? Okay, so next class, ma'am. So Vijay, are you asking me when will be my next class? Something like that? One more question. This is one more question if you can solve. The circuit shown below implement 2-input NOR gate using 2, 2 to 4. Okay, so I will be taking COA class, which will be, I guess my classes are like 25 and 27. I'll be taking something like TOC or COA, I guess. Wait, let me check and tell you. Yes, on 25, it will be my COA class, same. It will be from 11 to something like 2.5 hours class. It will be of COA. And on 27, I'll be having TOC class. And the timings are same from 11 only. Okay. So this is the last question. Can you just solve this question? What is the value of XYZ? To get the result, this A plus B bar. This is the last question. Try to solve this. Let's take the output as y here. So NOR gate, how to represent NOR gate using mux? No, the options are not given here. You just have to write the value x, y, and z values you have to write. Give me the values, like what is the value of x, what is the value of y, what is the value of z, likewise. Yes, absolutely correct. The x value is 0. Are you saying x value is 0, Jay? Y value is 1, z value is b. So this will be ab, this will be 0, it will go here ab. So if we will select this, so it will be 0 plus, if you will select a b bar, so this will be a plus b bar. Yes, correct. So okay, so the options are given. I'm so sorry, I wasn't able to see the options this side, so that's why I said that. Nishu, you were correct, like it was 0 1 b. I'm so sorry because the options were not visible this side, but option C was correct. So Jay and Nishu were correct, 0 1 b. Okay, so that's all from my side. Thank you so much for coming for this session and making it more interactive and nice. Okay, thank you so much, and I'll hope to see you all in TOC and COA classes. Okay, we'll have some more discussions on the question and on the theoretical concepts as well. Okay, thank you so much everyone.